All right, nice dance moves, Mia. What is this move called? Oh, the reflection. I like it. Today is all about reflections. How would you describe reflections? If you haven't already, pause the video now and complete the satellite simulation part 1 activity. It'll help you answer this question. Maybe you said reflecting is like flipping a figure or taking its mirror image. Or maybe you imagined the same figure flipped over a line. If so, you're absolutely right. A reflection is when a figure is flipped over a line. In this lesson, we'll reflect figures over 2 different lines, the x-axis and the y-axis. Let's start with the x-axis first. This line segment is our pre-image. Pause the video and reflect it over the x-axis to get its flipped image. When reflecting a figure over the x-axis, it'll be the same distance away from the line of reflection as it originally was, just on the other side. Since this point is 3 units away from the x-axis, its reflected point will also be 3 units away. And since this point is 1 unit away from the x-axis, its reflected point will also be 1 unit away. Having these endpoints drawn in can help give us a guide for where to sketch in the rest of the figure. Alright, now let's use a little animation power here to see this reflection in action. Hey, we were right! That's exactly where it ended up. Now, how did reflecting it over the x-axis change its coordinate values? Here are the coordinates of the endpoints on the pre-image. What are the coordinates of the endpoints on the image? Pause the video and figure out these coordinates now. You should have -2, -1 as an endpoint and 3, -3 as the other endpoint. How do these coordinates in the image compare to the coordinates in the pre-image? It looks like the x values stayed the same, but the signs on the y values changed. These particular y values were positive on the pre-image and are negative on the image. Interesting. Do y values always change signs when reflecting over the x-axis? Let's work through a problem together and find out. This problem says to reflect the pre-image over the x-axis to get its image, and explain how the coordinates of the pre-image and image compare. Okay, let's take this one step at a time. Start by reflecting this triangle over the x-axis. Pause the video and do that now. When reflected over the x-axis, this triangle ends up here. Great. Now let's explain how the coordinates of the pre-image and image compare. Here's a vertex on the pre-image, and here's the matching vertex on the image. What do you notice about the coordinates? Yeah, the x values stayed the same, but the y values are opposites. Is this also true for this pre-image point and where it ends up? Yeah, the x value is the same and the y value changed signs. Let's check this point too. What do you notice about the point -6, 0? Maybe you said it's on the line of reflection, or that it's the same on the pre-image and image. It looks like it didn't move. All of these observations are correct. But does it still follow our pattern? Does the x value stay the same and the y value change signs? X is definitely the same, but did the y value switch signs? Well, if one of these was positive 0 and one was negative 0, what would that mean? Positive 0 and negative 0 are just 0, so the pattern still works. Now let's get back to the problem. Using what we just figured out, explain how the coordinates of the pre-image and image compare. Reflecting over the x-axis only moves points vertically, so it only affects the y values. It makes sense that the y values are the same numbers but different signs since they are the same distance from the x-axis. We could say something like, when reflecting over the x-axis, the x values stay the same and the y values change signs. Now that we've summarized what reflecting over the x-axis does using word form, we can take this and turn it into a more mathematical summary using coordinate notation. What needs to go in this first blank to show that x values stay the same? Yeah, let's just keep it as x. What needs to go in this other blank to show that the y value changes signs? We need negative y, or the opposite of y. Next, let's look at what happens when we reflect over the y-axis. This problem says to reflect the pre-image over the y-axis to get its image, and explain how the coordinates of the pre-image and image compare. Start by reflecting this over the y-axis. Pause the video now so you can try this. Let's see here. This point is 5 units away from the y-axis, so I can go 5 units in the opposite direction to get its image. This point is 3 units to the left, so I can go 3 units to the right for its image. And this point is sitting directly on the y-axis, so its image would be in the same place. I can now sketch in the image with confidence using the points I identified to help me. Now, let's explain how the coordinates of the pre-image and image compare. Since these figures overlap each other, I'm going to make an organizer off to the side to help me keep track of points on the pre-image and their corresponding points on the image. 5, 6 becomes negative 5, 6, negative 3, 2 becomes positive 3, 2, and 0, 1 stays the same. Now that this is more organized, we can compare the x and y values in each pre-image and image. What do you notice about these numbers? Yeah, when reflecting over the y-axis, it's the y values that stay the same and the x values that change signs. Let's take this summary and turn it into coordinate notation. What needs to go in this first blank to show that x values change signs? Yeah, we can put negative x, or the opposite of x. And what needs to go in this other blank to show that y stays the same? Exactly. Let's just keep y as y. Now that we have reflections over the x-axis and y-axis all figured out, let's use this knowledge to try a few final examples. This says, what is the image of the point -2, -4 when reflecting over the x-axis? Take a moment to figure this out on your own. Be sure that you're reflecting over the correct axis. Since a reflection over the x-axis involves taking the same x value and the opposite y value, the -2 stays the same and -4 becomes +4. This is our answer. Okay, now what about this same problem but reflecting over the y-axis instead? Go ahead and answer this new question. Be sure that you're reflecting over the y-axis this time instead of the x-axis. Since a reflection over the y-axis involves taking the opposite x value and the same y value, the -2 becomes +2 and -4 stays the same. This is our answer. Now that we've developed these rules for reflecting over the x-axis and reflecting over the y-axis, the key is making sure we don't accidentally use the wrong rule and change the sign on the wrong number. But remember, you can always draw it out if you're unsure of your answer. Don't forget to finish up your tasks for today. And remember, math is everywhere. Keep exploring! Hey.